So 6 cos squared x plus cos x tan x equals 5. For 0 degrees less or equal to x, less or equal to 360 degrees. Give any non-exact answers to 1 decimal place. So we've got 6 cos squared x plus cos x tan x equals 5. Well, we know what tan x is. Tan x is sine x over cos of x. But we also know that cos squared x plus sine squared x equals 1. So this is the fundamental identity. This is always important to remember. But if I then replace cos squared x, make cos squared x the subject, I will get cos squared x equals 1 minus sine squared x. So what I'm going to do first is to replace this one here, tan x, with sine x over cos x. And I'm going to replace cos squared x with 1 minus sine squared x. So I'm going to get altogether sine function. So this is 6 here. So I got 6, open bracket, 1 minus sine squared x. So I'm using this identity now. This is fundamental identity, so I'm using that now. And plus cos x times sine x over cos of x equals 5. As you can see here, the cosine functions will cancel out. And then I have the next. So, and I'm going to expand this bracket. So I get 6 minus 6 sine squared x plus sine x equals 5. I'm going to move all these to the right, everything to the right. So I'm going to get, well, 0, because I'm moving everything to the right, equals 6 sine squared x, because that move that to the right, it will become, the sign will change when you move it to the right, minus sine x, because I moved that to the right, and minus 6 plus 5. And that meant I have 6 sine squared x minus sine x minus 1 equal to 0. I can see this is a quadratic function. I'm going to make sine x equals y. So you will say let sine x equals y. So therefore I get 6y squared, because that's y squared. This is sine x squared, so that's y squared. If I square that, I have to square this. Minus y minus 1 equal to 0. So I've got a quadratic function. In this quadratic function, the a, this will represent a y squared plus b y plus c equal to 0. So that's a quadratic function there. I want to factorize it if it's factorizable. So a equals 6, b equals minus 1, and c equals minus 1. So you can see that's B there. There's 1 here. Even though you can't see it, 1 is the default. Now, I need to apply the factorization process. So I need to find AC. That means A times C, which is minus 6. So if that's the case, I need 2 numbers. I can multiply together to get minus 6. And when I add them together, I'll get B, which is minus 1. And the 2 numbers will be 2 minus 3. 2 times minus 3 is minus 6. 2 plus minus 3 is minus 1. So next thing I need to do is to put y here and put y there. What that meant is 2y minus 3y, which just give me y. There you go. So that's it. That's y. And that's what I want. So I'm going to replace the minus y with 2y minus 3y. So now I'm going to write all this out now and replace the minus y, because that will be equal to minus y, because that's what it's equal to now. So I'm going to replace minus y with these 2 in that function. So we get 6y squared. I'm going to put minus 3y plus 2y. So that will give me minus y. And then I've got minus 1 equal to 0. So common factor between these 2. What's the common factor here? The common factor is 3y. So if I take 3y out, then I'll get 2y, because 3 times 2 is 6. Y times y is y squared. Minus 1, because 3y times minus 1 is minus 3y. And then plus. Then what's common between these 2 here? It might not be so obvious, but 1 is common. So if I take out 1, I know we don't write 1, so I'll just put 1 there. So that'll be 2y minus 1 equal to 0. Because 1 times 2y is just 2y. 1 times minus 1 is minus 1. See? So 1 is common there. Now, what's common between these 2? You can see minus 2y minus 1 is common. 2y minus 1. So that's my common factor. 2y minus 1. And then what's left? As you can see, what's left is plus 1, 3y. So I've got 3y plus 1, and that equals to 0. So I've just used quadratic function equation in trigonometry identity or trigonometry equation. These are the factors. I've done the factorization also. These are the factors for this quadratic here. Therefore, I need to set this to 0. Set it to 0. Set it to 0. That means 2y minus 1 equal to 0. Therefore, y equals a half. Minus 1 to the other side, and then divided by 2, you get a half. So y is a half. And what that meant is sine x equals a half. So that's the first one there. And the second one is when I set it to 0, 3y plus 1 equal to 0. Therefore, 3y equals minus 1, y equals minus 1/3. Therefore, sine x equals minus 1/3. So I've got 2 problems to solve. Now I'm going to solve trigonometry equation here. Sine of x equals a half. I know what a half is because I've seen this before. This is obviously to remind you when you do, I don't need to, I thought I'd just remind you why I've seen that before. If you do equilateral triangle, and that's 2, that means if you split that into 2, that's 1, and that's 60, and this is 30. So if you find a height using Pythagoras, you get root of 3. Okay, sine of 30 is opposite over hypotenuse. So that's sine of 30. So that meant x equals 30 degrees. So that's what is. That's what is that, and that's what that is. But we could obviously put it into calculator here and just find. But you have to do, to solve that, you have to do x equals inverse, because you have to divide that by sine. And then when you divide by sine, it becomes sine to power minus 1, a half. So if we do that, you do shift sine, inverse sine, fraction, 1, 2, close bracket, and equals, you get 30 degrees. So it's thing to know, but if you don't remember, you can still do it with a calculator. And from there, we now need to find the angle. What's the answer to this one? So I'm going to do that here. It's easy to solve that because I'm going to use a cast diagram. But sine is a half. Sine x is a half. In the cast diagram, sine is positive here, sine is positive. So it means that this is a half, and that's a half. So that's what that meant. So this is a half, and that's a half. And if you look at it, it means it goes like that. That's 30 degrees. So that's the half, and this is another angle here. So this is 30 degrees, but I want to find, what I'm looking for is, remember y-axis is sine, this is a unit circle, so r equals 1. And y-axis is the sine, x-axis is the cos. We're not interested in cos, we're interested in sine. So the angle, if I go from there to there, that's 30 degrees, and I need to go from there to there, and that's 150 degrees. Because 30 minus 180, so this is 180, that's 0, that's 90 degrees. So that's 90 degrees. So 30 minus 180 is, 180 minus 30 is 150. So those are the two angles I'm looking for. I'm looking for 150 degrees, and there will be the angles that are required. So my answer for 0 to 360, because I'm only using the positive a half, because the sign we're looking for is a positive value, not a negative value. This will be the negative value, and that will be the negative. This is minus a half, and that is minus a half. We're not interested in those. And so therefore, the angles we're looking for are x equals 30 degrees and 150 degrees. So that's the first solution. Now we need to find the solution to that. Okay, so to this one, again, we have to divide it by sine, and that will be x equals 1 over sine times 1 over 3 minus 1 over 3. And therefore, in indices, 1 over sine is sine to power minus 1, which we called inverse sine. So that's inverse sine. That means reciprocal of sine. Open bracket, minus 1/3. So we can find that value. So x will be equal to, again, with the calculator. So we put a calculator there. Brilliant. And shift sine, the fraction key, minus 1. Bring that down to get 3. Move the arrow to the right so you can close the bracket. And so you get 19.5 degrees, minus 19.5 degrees. So that is minus 19.5 degrees. So that's the angle we're looking for. Again, I need to draw a cast diagram for that. So that's cast diagram. But we want minus 19, so we're looking for minus 19. So minus 1/3. So that's minus 1/3. So that'll be 1/3 minus. And this is also here, y is negative. So you get minus 1/3 there. So that means the angle there is 19. So that's 19.5. And the angle here is 19.5. So the minus tells you what to do. Remember, when we do a cast diagram, whenever we do a cast diagram, this is the y-axis is sine, and the x-axis is cos x. So always remember that, and also to remember that we measure angle from 0 degree in an anti-clockwise direction, 90 degrees, 180 degrees, 270 degrees, back to 360 degrees. So that's what we've got here. So that's 0 degrees, 90 degrees, 180 degrees, 270 degrees, back to 360 degrees. For the angle we're looking for, we have to start from 0, right? Because it's always important. We measure angles in anti-clockwise direction. So we start from 0. We need to find that angle. And also we need to find these angles. So those are the two angles we can find in the boundary. With the boundary we've got is 0 to 360. So within that, those are the two angles we can find. And the first one is here. So that's 180 plus 19 will give us, so this angle will be 199.5 degrees. And this angle here is 360 minus 19 because it's below 360 here. So if you go all the way to 360, you're 19.5 degrees short of 360. So this will give us 340.5 degrees. So the answer to the questions we've got is, the first part is x equals 30 degrees. Then you've got 150 degrees. And then you've got 199.5 degrees. And finally, you've got 340.5 degrees. Those are the answers. Remember, these answers are to 1 decimal places for any non-exact answer value. These ones are exact, 30 degrees. That means there's no decimal point. That one is exact, 150 degrees. The non-exact is the one with the decimal point, and the decimal place has to be 1, and that's fine. It's 0.5 degrees.